Hello guys, welcome back to my channel, and today we're going to start with a brand new chapter, that's Euclid geometry. So let's begin. Now, geometry is a combination of two words derived from Greece. Geo means earth and metron. Metron means measure. Okay, Greek mathematician Thales is known to have given the first proof by explaining a circle is bisected by the diameter. Okay, so Thales gave proof that a circle is bisected by a diameter. Okay, now Euclid, let's talk about Euclid. Now Euclid was a teacher. Euclid was a teacher at Alexandria in Egypt. Teacher at Alexandria in Egypt. And he collected all the facts around him, through which he wrote a book. Okay, a really huge book which contained 13 chapters. Actually, nowadays we call the books that we're writing on, okay, the pages that we're writing on, we call them books. But at that time, he named the chapters inside that book, inside that huge book, as books, not as the whole book. Well, this will be a confusing one actually. So he collected facts and combined them in one single book. Okay, it contained 13 chapters. Okay, and what was the name of this book? Well, the name of this book was Elements. Okay, name of book was Elements. Okay, now let's talk about some of the definitions introduced by Euclid. Okay, I'm not going to write it now, so you need to hear and then write it in your book. Euclid's definition. A point is that which has no part. Okay, a point which has no part. It doesn't have length, breadth, or height. It is just a fine dot like this. Here you can see this is a fine dot I have made over here. Okay. A line is breadthless length. Okay. Suppose here I draw a line. Okay. So does it have any breadth? I will draw a 3D figure. You will understand better. So this is a cuboid. Okay. Now this is the length. This part is the length. But does it have any breadth? No, it doesn't have any breadth. It is just one single line. Okay. Now, the ends of a line are points. Let's draw another line. And if I name this is a point over here. Yeah. Here there are 2 points at the end of the line, A and B. So these are called the points or the end of the line. Okay. A straight line is a line which lies evenly with the points on itself. Okay. Now suppose I draw some fine dots over here like this. One over here, one over here, one over here, one over here. Okay. And then through them I draw a line. Let's just say not through them, but on them. Okay. It is passing right over the points. The line is passing right over the points. So we can say that a line is perfectly lying on the points. Okay. Now the next fifth one is a surface is that which has length and breadth only. Okay. Now suppose I draw a rectangle over here. So what can you observe? That it has only length and breadth. It doesn't have height. Okay. It has only length and breadth. Now the sixth one is the edges of a surface are lines. Okay. Now suppose I draw this kind of figure over here. Okay. Now these edges over here, these are lines. Sorry, these are lines actually. These over here are called lines. Okay. Now the seventh one and the last one is a plane surface is a surface which lies evenly with the straight lines on itself. Okay. Now let's talk about some undefined terms introduced by Euclid. Now, what do you mean by undefined terms? Undefined terms are terms which were not properly explained by Euclid. Okay, at that time he knew that okay, this is this and this is the definition of it. But I am not able to properly prove that that this is the actual thing. This is an actual fact. So these are called as undefined terms. Undefined terms. Okay, now the first one is point. Point is the first one. Now it has neither length nor breadth nor thickness. It is represented by a fine dot. Okay, so it neither has length. Length, no, it does not have. Breadth, no. And height, still no. Okay, so it doesn't have these three factors. But one thing which he does know, that Euclid does know, is that it is represented by a very fine dot over here. As you guys can see over here, it is a really fine dot. It doesn't have any length or breadth, anything. It doesn't have length or breadth. It is just a dot. Okay. Now let's talk about line. Okay. Line. If we fold a piece of paper, suppose you have a piece of paper like this. Okay. Now if you fold it and then you reopen it, okay, you will see that there is a fine line over here like this in the middle. Okay, I will show you it by a different color. This red color symbolizes the fine line or the crease, you can say. Try doing this at home. Fold a paper and then you will see that a straight line is formed. So that line is actually called line. Okay. So the line, this line cannot be drawn fully. Okay. This line you see over here, it cannot be drawn fully. Okay. It is infinitely, like it has a length which is infinitely going on. Okay. It can neither be counted. Now let's talk about plane. Okay. Plane, a flat surface extends indefinitely in all directions. Okay. Now let's talk about some well-defined terms. Okay, these are terms which were defined really well by Euclid at that time. Okay. Well-defined terms. Line segment. Okay. Suppose I draw a line over here like this. Okay. Let's not draw these arrows. Let's just say here. This line is extending infinitely. Okay. Where I don't know. Okay. But there is a small portion of this line which I have selected, or I have taken 2 points and put it on this line. Let's name them A and B. Okay. Now this portion you can see over here. Now the rest of the whole line, let's say, come on. This is a line. Its length is 15 centimeter. Okay. But I took 2 points A and B over here. and this portion over here measures only 5 centimeter. So the portion which measures 5 centimeter is called line segment. Okay, so it can be written as AB or BA. No matter which way you go, it is the same. Now, remember the line segment always has 2 points. Never forget that. A segment is completely known if its endpoints are given. Suppose if these 2 points are not given, okay, then this is just a plain line. This is just a line which is extending infinitely. You don't know anything about it. Just one thing, that is it is extending infinitely. Nothing else. Now, let's talk about ray. Okay, and by ray, I'm not saying that the ray of the sun and all. Suppose you have this line over here. A ray is a line segment which can be extended in one direction only. Okay, suppose I have a point over here which is A, and this I will draw a ray over here. This is the symbol for A, sorry, ray. Okay, and one more point over here, that is B. So B is extending infinitely. Okay, and we will denote it by AB in the direction of B. Okay, suppose if it was other way around, okay, then what will you write? You won't write AB and then arrow over there. Now, if it's like that, then you have to write BA, and the arrow should be towards B, sorry, A. Okay. Now let's talk about opposite rays. Opposite rays. Two rays, AB and AC, are said to be opposite rays if AB and C are collinear and A is the only common point of the two rays. Let's just represent it by an example. Okay. So here we have a line. We have given it two rays, let's just say, and here we have B. Here we have A, which is the common point, and here we have C. Now, if you write it like this, BA, and line over here, and AC, and a ray over here, what can you say is common between the two? A, you can see. So if two common points are there, sorry, only one common point is there, that means it is opposite rays. And one more thing, that the rays must be facing opposite to each other, or they must be forming an 180-degree angle. Only then they are opposite. Now, two common points are there, thus not opposite. Okay, remember this. Suppose this is over here, one common point. Line is extended like this. And one point is over here, that is A, and this is O. Okay, and this point is B. Now it has two common points, OA and OB. Right, so this is not a ray, sorry, not an opposite ray. Okay, since they are facing the same direction actually, that's why they are not opposite ray. Okay, now let's talk about the actual beginning of this chapter. Now all of this was just the basic, the introduction. But now we're going to start the real Euclid geometry. And in Euclid geometry there are two things, postulates and axioms. Let's talk about axioms. Axioms. Now these are the actual rules that you need to remember. Okay. Now the first rule is things which are equal to the same thing are equal to one another. Okay. Suppose A is equal to B and B is equal to C. Then it won't be wrong to say that A is also equal to C. Now we can say that A, suppose it has some kind of value, let's just say 1. So one value is equal to B. So both of them have same values. Now if we say that B is equal to C, C also have one value. That means A and C, they are equal. Right. Now, second axiom. If equals are added to equals, then the wholes are equal. So A is equal to B That means if we add something on both the ends, so A plus C is equal to B plus C. Okay, so they're equal. Now let's show this by an example. You will understand better. X minus 17 is equal to 3. Now x minus 17, let's add another one. Let's add 17 only. Then 3 plus 17. Now because there's minus sign, 17 will get cancelled. So x is equal to 20. Like this. Let's talk about the third axiom. If equals are subtracted from equals, then the remainders are equal. Okay. A is equal to B. Okay. So A minus C is equal to B minus C. So whatever the remainder comes, okay, that is going to be equal. Now, fourth axiom, things which coincide with one another are equal to one another. Now, if I have two lines over here, okay, and now A, B, and C and D, and both of them have 5 centimeter length. Okay, that means they're equal. That's it. Now there are a total of 8 axioms over here. So 8 of them are really important. Now, fifth one, the whole is greater than the part. Now this must be a bit confusing. Now, I have this circle over here, although it's not perfect, but you will understand. Let's draw a line over here and divide it into two parts, two equal parts. Okay, then one more line. Now it is divided into 4 equal parts. Now suppose I take this part over here, this part, I'm shading with it green. Now this is 1/4 of the whole circle. Okay, and if I consider the whole part, the whole circle, we'll take it as 1. Now if we compare the two, which one is going to be bigger? Tell me. 1 is smaller than 1/4 or 1 is greater than 1/4? Okay, that now the answer for this one is this one. 1 is greater than 1/4 because the part is greater than the whole. Sorry, the whole is greater than the part. Okay, let's talk about the sixth one. Sixth axiom is things which are double of the same thing are equal to one another. Okay, suppose A is equal to B. Okay, now if I multiply 2 into A, that means that B is also going to be 2 into B. So if we just double both of them, their values are going to be same. 2A is equal to 2B. Okay. Now the seventh axiom is things which are half of the same thing are equal. Now this is the basic thing. Okay, suppose if I half A, so A by 2, and I also half B by 2, they are going to be equal. Okay, equal. Now the last one is, if the first thing, here you have to concentrate. Okay, this one is a bit long, so you might get confused. If the first thing is greater than the second and the second is greater than the third, then first is greater than the third. Did you get it? If not, I will explain. Okay, so A is greater than B and B is greater than C. So won't it be right to say A is also greater than C since it is smaller than B? Right. So A, you can say, is the largest value. B is a bit smaller than that and C is even smaller. So if we compare A and C, Which one will be bigger? Of course, A. Right, done. Now we have completed Euclid's axiom. Okay, in the next video I will complete Euclid's 5 postulates. Okay, which is really important. Now, this is it for today. I hope you enjoyed this video, and if you do, please make sure to subscribe my channel and like, and also make sure to share it. Okay, till then, bye bye.